that may be kind of difficult to understand, especially in a non-programming class. So we'll go ahead and explain all of these things, step by step. A program is basically a set of instructions for computers to follow, to execute. In other words, your computer, the physical box here, is nothing more than a space heater without software. Okay, you need software to make a computer useful. It's just kind of like the hardware is nothing more than, I would say, workers in a factory. So let's say you have honest, hardworking, really good workers. They're very skilled, but you don't tell them what to do in the factory. They are not going to be very helpful, right? Because they will just be standing around doing nothing because nobody tells them, oh, okay, you are responsible to assemble this piece by putting this piece together, and then put a screw through here and then tighten it to a certain torque and so on. And you have to take that piece and then add some additional pieces to it. So if you don't have instructions, all those workers are just standing around doing nothing. And it's the same thing here. Your computer, the hardware, whatever you can see, is basically a factory with workers. Okay, but if you don't give it any instructions, it's not going to be very helpful. It cannot do anything meaningful. A program is like the instructions. It's like an operation manual to those workers in a factory. Okay, it is specifically saying, okay, you have to start with this step here, perform this step, and then this step. Oh, now at this point, you can go this way or you can go this way, depending on whether this variable is larger or the other one is larger, and so on and so forth. So that's what a program is about. It is software. It tells the computer what to do. The source code, now this is a little bit longer because it takes a little bit more to explain what is source code. A program is usually written in a language that is human-friendly. I should have put human-friendly in quotes because it takes quite a bit of education and also training in order to program in a particular programming language, because the syntax or the grammar of a programming language is not necessarily the most user-friendly, even though programmers try to make it so, but it's not really that user-friendly. But it is still friendly compared to what we are going to talk about. In order to execute, to run a program, like double-click on an icon so that you can use a program, the program has to be translated into machine-readable form. Machine-readable form means it is all specified in zeros and ones, long strings of zeros and ones. The processor can take that long strings of zeros and ones and say, oh, I know what to do with it. Okay, and you can execute it at very, very high speed. But that's not what we understand. That's not how we program the computer. Even experienced programmers do not program in zeros and ones. Now, if they have to, they can read the manuals and actually be able to specify a program completely in zeros and ones. But then I'll be writing programs very, very, very slowly if I were to write programs that way, because it's just not natural for people to think in the machine code format that is natural to the processor, but not so natural to a human being. So that's why for us, even with experienced programmers, we want to program in a high-level programming language, but when the computer executes it, it has to execute it in zeros and ones forms. Yeah.
And 0 and 1 form, you'd be dealing with a lot more code too.
Yes, you'll be dealing with many of the instructions in zeros and ones will be one single line in the source code that is human readable. That is absolutely correct. So that's why we don't want to do it that way, because it is not very efficient. If we have to program in machine code, I don't think we'll have computers that we have today. We won't have the software that we have today. We'll still be in the dark ages of computers at this point. Okay, we are at this point, with our cell phones, with all the apps that we have on the cell phones. It's only because we have programming languages that allow people to write programs in a fairly quick way. Okay, without high-level programming languages, we'll still be using clunky old computers. Because it doesn't matter how much RAM you have on your computer, because your programs won't be that long. Because it's impossible to write any programs that are complicated or sophisticated. So are we still doing okay so far with the concept of source code? Okay. It is generally impossible or infeasible to get the source code given by the machine code readable code, which means it's a one-way street. Okay, if you have the source code, which is human readable, you can translate that into machine code, which is native to the processor. That step is easy, okay? But the other way around is not. However, given the source code in translation tools, one can create the machine-readable form so a computer can run the program. And this step is usually called compiling, depending on the programming language. With C, C++, and Java, it is called compiling because it's a one-step process. With Perl, PHP, Python, and so on and so forth, it's called interpreting. Okay. Now, I didn't really write down the differences here, but we will come across this again when we talk about programming in this class. The difference between compiling and interpretation is whether it is permanent or is one step at a time. With compiling, it's kind of like, let's say I'm the compiler, okay? With compiling, it's like somebody giving me a whole big pile, the entire program, okay? Written in source code, human readable form, and I have to go through this entire pile and come up with an even bigger pile of machine code, but I'll do it in one shot, okay? So once I have the machine code, then I just give the machine code to whoever gave me the source code and say, okay, this is now machine executable, don't bother me anymore. Okay, so they can now redistribute the software, in machine readable form, to as many people as they want. Yep.
This is under the assumption that the source code is error-free?
Correct. If I make any changes to the source code, I have to go through this entire process again. Exactly, I have to recompile. But assuming the source code is not changed, okay, I only have to go through the translation once, because I'm basically translating this entire pile in one shot and come up with an even bigger pile of translated material, which is the machine code, and the machine code becomes the program that you download or install on your computers. Okay, so that's one way to do it. This is called compiling. It's a one-shot process. Now, interpretation is different. Interpretation means, let's say I'm the interpreter. The interpretation means, oh, okay, you want to execute the first line, you want to start executing this program. I'll read the first line. Oh, okay, I know what that means. And then I'll tell the processor on the other side what to do. And then I'll move on to line 2, and I'll go like, yep, I think I can see what line 2 is about, and I'll tell the processor what to do. In other words, I'm doing translation only one line at a time. Now, what if the execution of the program goes back to line 1? I'm going to reinterpret line 1 to tell the processor what to do about line 1 in the source code. So I'm translating only one little sentence at a time, and I'm retranslating things that I have already translated earlier, because nobody bothers to store that code that is already translated. I know some of you know what is Java and hotspot optimization and stuff like that. So just-in-time compiling and stuff like that. So I'm kind of simplifying this and not take that into consideration because I don't want to create a big old mess here. All right. So are there any questions? Compiling is one shot. You give me a big pile, I'll give you an even bigger pile. Interpretation means it's step by step. I only have the source code, but with each line to execute, I'll translate that in real time to the processor. Yep. They both have advantages and disadvantages. We will come back to this topic again when we talk about programming, but I can give you a short answer to that. If you want efficiency, execution time efficiency, if you want your programs to run fast, okay, and be able to use as little processing resources, including RAM and processor time, you want it to be compiled because you don't want the interpreter to keep interpreting the same thing over and over again. On the other hand, if you want your program to be easy to distribute, if you want it to be easy to change, okay, if you want to make little changes here and then be able to run the program again, or with no disruption whatsoever, because of one little change, then you want it to be interpreted because nobody has to translate a whole big pile of code into another form, every time you make a little change. Okay. So there are pluses, advantages and disadvantages to each approach. It all depends on what is your application. If your application is like a web application, interpretation a lot of times is actually a better way because you don't have to shut down the website and recompile everything and then reactivate the whole website. On the other hand, if you're running an application like a browser or something like that, you want it to be compiled because you don't want the browser itself to take up too much resources. We have enough JavaScript and stuff like that to take up all the processing resources already. The browser itself doesn't need to be another overhead that we have to worry about. All right. So out of this entire paragraph, what we need to know is with the source code, we can always get to the program and get it to run. But if you only have the machine code, then you can only run the program, but you cannot reverse it back to the source code. The third one is just the term software itself, because I talk about software license here. Software is a general term that refers to instructions for computers to execute or to follow. Software is not countable and program is. And a license means it is a document that lays out all the restrictions, rules, and terms of using something. So licensing does not only apply to software, it also applies to other things like patents. Okay, you guys have most of you have heard of the big lawsuit between Apple and Samsung, and they're having what we call a patent war. Okay, patent wars are not unusual at all, especially in the software industry. Okay, it happens everywhere. Even with locks. Okay, you go to Home Depot and then you go through the lock section. All of those lock manufacturers are engaged in all kinds of patent wars all the time. But the intensity is not nearly as much as in the software and the high-tech industry. So what exactly is a license? Well, it is just a document that will lay out the restriction terms and rules of using something. In the case of licensing in, let's say, cameras, okay, let's say Canon came up with a really great idea of autofocus, okay? I'm just picking that as an example. And Nikon says, I want that too, okay? I want to be able to use the same technology, so let's sit down and negotiate, okay? So in one negotiate situation, Canon can say, well, I can let you guys use this technology, but I want a cut, okay? So every time you sell a lens using this technology, I want 5% of the sale price, of your profit, or whatever. Okay, it all has to be laid out in the terms, and then Nikon can go through that agreement and go like, yeah, I guess we can live with this, because with this technology we can sell more lenses, so giving you 5% of the cut is not a big deal. Okay?
But still, don't you have to ask permission though?
Yes. So Nikon has to sign the document to say that they will play by those rules with respect to Canon. Now, what if Nikon later on decides, you know what, I think we can steal that technology and not let Canon know about it? Well, what if Canon cuts apart a Nikon lens and finds out, hey, this is the same technology and they're not paying us for this particular lens? They can sue it. Okay, so in that case, Canon can sue Nikon for infringing the not the copyright, but the patent in this case. Okay, so there can be legal action if the terms of a license is not followed. And that happens all the time. Between Apple and Samsung, we are involving billions of dollars in the lawsuits now, right? Let's look it up.
At least billions.
Well, yeah, but billions for those companies is not as much money as we think. Samsung license, and just type Apple. Apple offered to license patents to Samsung didn't include iPhones. Okay, so they're arguing about what is actually licensed. This iPhone's interface, I guess the feel and look, probably is in dispute at this